Hi, I'm Joey. This is my face, my hands. I've gotten 2 mils of ethyl acetate and 8 mils of heptane for 10 total mils. I put the lid on after I took it out so it doesn't evaporate. We're gonna put my filter in first. Just so the bottom's in there on the side. Close the top. And then I'm gonna shake it around so the vapor saturates the entirety of my jar. Thank you.
This is not perfect, jar.
All right, looking pretty good. All right, so now that we've got our jar ready, we're gonna start with our plate. So as you can see, there's a shiny side and a dull side. We're gonna write only on this side, otherwise it's not gonna work. So first, we're gonna figure out where we want to draw our line. And in order to do that, we're gonna kind of measure, because the line has to be above where our solvent is in here. So we're gonna put it, let's say about there. And we're gonna get something straight here. Kind of to measure it across and see how we have a nice line like that. Now notice when also I'm handling it that I'm only grabbing the edges, as any oil will mess up with the experimental procedure. Additionally, we're going to put some hashes in order to where we're going to put our dots. We're going to have 2 hashes, one on the left and one on the right. And try not to get these too close together or too close to the side, or that will mess up the experiment. Now we're gonna make 2 dots on our chromatography plate. Note how I made this line a little bit too hard. So we're gonna actually put the dot to the side of it in order to avoid that error. So on the left side, we're gonna put fluorone, and on the right side, we're gonna put fluorine, which we have over there. As you can see, I have my micro pipette here. I've watched out for jagged edges, and so this side is pretty flat. We're gonna take our sample, and through the capillary effect of our pipette, we're gonna dip it in. It's gonna hold it in there. We're gonna make sure there's not a big drop on there, and quickly we're gonna tap it right on that line and pull it up. And that's a little bit above that line, so I'm gonna try to do the same with the other one and record that. And then give that a second to dry, and another tap. Should I go back in and tap? No. Probably shouldn't comment this on the video. So that's the first one, and I will proceed with the next one in the same manner. Cut. Ready? All right, now we're gonna place our second dot, which is fluorine, which we're gonna put on the right side here. Again, we've checked for the jagged edge. We're gonna open our fluorine, put our micro pipette in to draw the fluid up. As you can see, we've got some in there.
Cap it.
Cap it before we place. And then we're gonna just hold this down and it's not quite a tap, we're refining my technique, take note. And we're gonna put it right like that, give it a second to dry. And we're gonna hold it a little bit longer this time.
There you go.
Bam. And we had a much better sample on that one. Okay, now I've got my plate with my 2 dots, and it's ready to go into the solution with my filter paper in my jar. So it's important again that I'm holding this on the sides to avoid any oil on the surface. And then when I open this up, I'm going to want to place it on the opposite side of the paper. Make sure that the line that I've drawn is above this solution, or it won't work at all. And then make sure that I want to pull this out when this gets about 80% or 5 to 10 millimeters from the top, okay? So we're gonna take this off, put it in, and then put the cap back on to avoid any vapor from escaping, or as little as possible. So we're gonna open this.
Yeah, we're getting around another one.
We're gonna be very careful in trying to get this right in the bottom. Just try to lean this in here. Nope, you just drop that in. Try to lean this up, come on. Lean that just like that. Put that top back on. And now we will wait to allow the capillary effect in the paper to take place.
The solvent.
Note how the solution is moving upwards. It's about 50%, 80%. We're gonna cut it. All right, if we can get in here now, we can see that our solution is at about 80%. I realize with the glare kind of hard to see, but it is there. So we're gonna get ready to take this out. We're gonna take the top off. We're gonna go in, and we're gonna still make sure to touch only on the sides. And as you can see here, that's about 80%. Maybe a little bit longer, but it's pretty close. So we're gonna put this down.
And we just
Okay, and we're gonna let this dry, but before we let it dry, we're gonna mark where the solution front is. We're gonna take our book again, and we are going to, it's right here, mark our line. And this is going to be needed for our calculations. If we waited until afterwards, the solution would keep moving up, which would error in our calculations. So now we're going to let this dry, and then we're going to look at it under the fluorescence. Okay, so now we've let our sample dry. We are going to look at it under the fluorescence so we can tell where our two dots that we put initially ended up in order to calculate the RFs eventually. So first we're going to look, if we can look into the fluorescence here, and we can clearly see our two dots. As if you can remember when I was putting the dots down, I kind of messed up on that first dot, and that's the reason for the error on the top side of the plate. But now what we're going to need to do under the fluorescence is on this dried plate is we're going to want to circle them, because once we take it out of the fluorescence we won't be able to see it. So in order to make our calculations, so we're going to go ahead and circle it with a pencil here. There's our one, and here is our next one, and that is perfect. Okay, so now that we've gone to the fluorescence with our dried plate and circled the two spots where our fluorescence showed, we can now calculate our RFs. So first, in order to calculate the RFs, we're going to want to find our A values. Now, A values are going to be the distance from our initial line to the center of our fluorescent spot, okay? So we're going to draw that here, this first one. Let's get this in centimeters. To the middle of that spot, it's right about there. And we're going to draw that line there. And then we're going to do that for our second one, which is fluorine. Again, we're going to get our dot of where the middle of that is. Going to measure that straight up and straight down and draw our line there. And as we can see, our A for fluorinone is going to be right at, actually, it's going to be 1.90 centimeters. So moving up here, we're going to put for our fluorinone, and we have our fluorine over here, our A is going to be equal to 1.9 centimeters. And moving back to our fluorine, we're going to measure from the middle of that dot 3.00 centimeters. A equals 3.00 centimeters. Now it's necessary to calculate our B value, which is actually going to be the same for both our fluorinone and our fluorine. To calculate our B, we're going to go to where the solvent went, to where our starting line was at, to where we put our dots at. So to measure that, we're going to take our centimeter ruler again. We're going to draw a line. A little bit softer this time. This was a little too hard, but that's okay. And we measure this at about 5.30.
What's the units on it?
Centimeters. 0 centimeters. And as I said before, that's actually going to be the same for both of these spots.
Okay, we'll go follow units.
Now, in order to calculate our RF, we're going to use the formula RF equals A over B. Okay, so now we're going to look at how to calculate our RF measurements. So first, as we said before, this is our equation. RF equals our A over B. A, again, if we go back to this, is our distance from our starting line to the center point of the solvent, or of the dot made by our spot. And our B line is going to be from that starting line to the solvent front that ends up here. So, knowing this formula, A over B, we can do these two calculations for our fluorinone and fluorine. So fluorinone will have our RF equals A over B, which equals 1.9 centimeters over 5.30 centimeters. And doing the math, we'll find that
Little show off.
There we go again.
You do know
gives
we
us
left, right? Was right.
0.358.
Much better doing right.
Again, we'll do that calculation for our, kind of go like that. For our fluorine, we'll have RF equals A over B, which equals 3.00 centimeters over 5.30 centimeters. And that'll give us an RF of 0.566. So you can see through this TLC technique, we have calculated the two RFs of our fluorinone being at 0.358 and of our fluorine at 0.566. Hands, face.